So without psychology, we can't understand how these instances are possible, why some people get sick and other people don't. So psychology takes health beyond being just the absence of illness and expands on it to include the influence of all these contextual factors. So to understand how we got to where we are, we need to look back and see where we've been. So the foundation of health psychology is this understanding that there's a significant relationship between the mind and the body. And that wasn't always the understanding. This relationship has undergone a lot of transformation throughout history. So starting with prehistoric times, the mind and the body have been considered intertwined all the way back to prehistoric times. But back then, diseases were believed to arise when evil spirits entered the body. So if you think of that famous scene in The Exorcist, which I have not seen because I don't do well with horror movies, but pretty much everyone's seen that scene, or at least pictures of it. So that scene where she projectile vomits everywhere because she's possessed. If you lived in prehistoric times and began vomiting uncontrollably, as she did, you'd likely be labeled as possessed by an evil spirit. And treatment would consist of attempts to exorcise that entity that has possessed you. So compared to nowadays, there weren't no bowls of chicken noodle soup, no renditions of Soft Kitty to make you feel better. Now, moving to ancient Greek times, the ancient Greeks were the first among civilizations to identify the role of bodily factors in health, and they developed a humoral theory of illness. So according to this theory, there were 4 humors of the body, and that referred to circulating fluids of the body. So they were blood, black bile, yellow bile, and phlegm. So when the 4 humors were out of balance, a person became ill. So as you might surmise yourself, treatment would then involve restoring those humors back to balance. So the Greeks believed also that the mind was important and the 4 humors could be associated with personality. So blood was associated with a passionate temperament. So if you think of that term, like that made my blood boil. Black bile associated with sadness, yellow with anger, and phlegm with a laid-back approach to life. So we know now that that theory isn't necessarily true. Your bodily fluids don't just get out of whack and that makes you ill, or, there isn't really a humor associated with a personality type. However, connecting the mind and the body with health and illness was a huge breakthrough at the time, and we know that that does carry a lot of truth and validity. So moving on to the Middle Ages, supernatural explanations for illness once again gained popularity, but there's an emphasis on religion here. So in these times, the church controlled medical knowledge, and because of this, medical practice had a lot of religious overtones. So in this case, disease was regarded as God's punishment for doing sins or any kind of wrongdoing. And thus, to treat illness, these evil sin forces had to be driven from the body. And often this was done by torturous methods. And later, this form of therapy or treatment was replaced with prayer. So you could repent your sins to God and pray, and hope that through God's forgiveness, you became healthy once again. So because the practice of medicine had such religious influences, priests often absorbed the functions of physicians and would carry out those actions. Thus, religion and healing were virtually indistinguishable. Now, starting in the Renaissance period and up to present day, we started to understand the technical bases of medicine. So here's where the scientific method began to be used as a guideline for researching health and illness and developing treatments and seeing which treatments were effective. So major advances in this area included the invention of the microscope in the 1600s and the science of autopsy, to find out why someone died, what actually happened in their body. Medical practice began to rely on laboratory findings and look to bodily factors rather than the mind as the basis for health and illness. So something's going on in the body, and we'll figure out what that was. So to break from past superstitions and break from this idea that if you're sick, it's because you're possessed or because you've sinned or God is punishing you, practitioners resisted acknowledging the mind as having any role in health, illness, or disease to avoid that slippery slope back into exorcism and like superstition. Instead, diagnoses and treatment recommendations were made on the basis of organic and cellular pathology. So what's actually going on in your body to cause how you're feeling? And from this, the biomedical model was formed. So the biomedical model maintains that all illnesses can be explained on the basis of bodily processes. However, as with anything, there are some significant downfalls to this biomedical model, especially when you consider other determinants of health, like social and psychological influences. So, first of all, this model can oversimplify illnesses, reducing them to these lower level processes like disordered cells and chemical imbalances, which I can imagine is actually a very complicated picture, yet it does exclude a lot of other contributing factors and boils it down to just the cells, so to speak. So this doesn't take into consideration that many other illnesses have other aspects like social and psychological functioning, and the picture is often a lot more complicated than that. Second, the model excludes social and psychological processes as powerful influences over bodily states. So one way to kind of picture this is if anyone has any experiences with psychologists or psychiatrists, and often people kind of look at them as being the same. Psychologists are trained through the scientific method, but taking into account psychological, biopsychosocial processes for health and illness. Psychiatrists, and this isn't my training, so I may be oversimplifying things, but they're trained under the medical model. So they're often trained to look for cellular and chemical imbalances as reasons for a mental illness. So that's why oftentimes psychiatrists may not have the same understand or may not be on the same playing field, so to speak, as psychologists are when they conceptualize how people develop illnesses and what mental illnesses and what's going to help treat them. Because the psychiatrists are often practicing under a biomedical model, and maybe less so the biopsychosocial model that psychologists are trained with, which we will get to shortly. So this biomedical model excludes these social and psychological processes as having this powerful influence, which means that social and psychological processes aren't included in this conceptualization of illness. They don't think you're having a flare-up of rheumatoid arthritis or fibromyalgia. I wonder what's going on psychologically or socially and whether this is having any impact. So further, it assumes a dualism of the mind and the body, which means that the mind and the body are separate and distinct as opposed to interrelated. So it really takes away from the idea that the mind is having any interaction with the body when it comes to health and wellness. So third, this model emphasizes illness over health, meaning researching and paying attention to illnesses and when people are ill and those diseases, as opposed to health and wellness. So instead of focusing on prevention and promoting healthy behaviors that may stop illnesses before they start, the biomedical model focuses on treating those illnesses and figuring out where they came from. So this approach to illness can kind of result in being late to the party, kind of. So we know that it's easier to cut things off, get ahead of the illness or whatever it is before it starts. So prevention can save a lot of time and effort. Like imagine if an illness never came to fruition. Imagine if this pandemic never came to fruition because we were able to prevent it from ever happening. Obviously, it's not that simple and it's not always possible, but it's a different way to look at things. Instead of focusing on the illness once it's there, focusing on prevention and promoting healthy behaviors that might stop the illness before it starts. The biomedical model doesn't really take that approach. So healthcare workers might be attempting to treat an illness after it developed instead of trying to prevent it from developing in the first place. And finally, the biomedical model can't address a lot of those puzzles that I've already mentioned that medical practitioners face, because many of these puzzles arise because of social and psychological factors that the biomedical model is excluding. So why would only 2 out of 10 people exposed to a virus develop symptoms? Things like that. The biomedical model can't answer those because a lot of times it doesn't go down to the cells and the chemicals. It goes to these other contextual factors. So the biomedical model is very important, and it was a huge step in the conceptualization of health and illness and understanding that a lot of health and illnesses result from physical changes in our body, and it can't account for the entire experience of health and illness. So this model would later evolve and be replaced with the biopsychosocial model that I mentioned, which includes the influence of psychological and social aspects. So, as modern psychology developed, the view of the biomedical model began to change, and a huge contributing driving force in this was Sigmund Freud's work, and particularly his work on conversion hysteria. So Freud stated that unconscious psychological conflicts would produce physical disturbances, and these disturbances would develop in a way that kind of symbolized whatever those repressed conflicts were. So for example, an individual that may have had a history of being neglected by their caregivers, feeling like unseen, feeling like they were invisible, or that their caregivers were blind to them, may suddenly become blind themselves. So this unconscious wrestling with accepting the neglect could manifest into like an actual loss of sight. So although this isn't a central and supported view, it gave rise to this idea of psychosomatic medicine, and that physical ailments can come up due to psychological causes. So psychosomatic medicine specifically is the idea that physical illnesses may be produced by internal conflicts. And 2 primary influencers in this area were Dunbar and Alexander, and specifically, they had linked patterns of personality to specific illnesses, such as an ulcer-prone personality. That's my other dog. He's a little barky, so he's not going to be making a lot of appearances. So there could be an ulcer-prone personality existing in someone with excessive needs for love, like stressing themselves out so much that they develop an ulcer. So Dunbar and Alexander maintained that these internal conflicts can produce anxiety, which becomes unconscious, and meaning that we're not necessarily aware of it, and through the autonomic nervous system, which we'll talk about in chapter 2, but that's the one that contains the fight or flight and the rest and digest systems. So through this system, takes a physiological toll on the body. So the sympathetic nervous system, that fight or flight response, and the parasympathetic, that rest and digest, are activated in times of stress and anxiety. So Dunbar and Alexander maintain that these internal conflicts produce this anxiety, which would trigger these nervous systems and these physiological responses. Because if you've ever been really anxious, when that fight or flight response is kicking in, you might have a lot of physical feelings too. So this would take a physiological toll on the body. So Dunbar and Alexander helped shape this field of psychosomatic medicine by showing that psychological profiles of emotional conflicts could be common in certain disorders like ulcers, hypothyroidism, rheumatoid arthritis, and several others. Now, in present day, we know that, again, that's kind of oversimplifying things. A particular conflict or a particular personality type isn't sufficient enough to produce a specific illness. Everyone with ulcers doesn't have the same historical conflicts or the same personality. Instead, illnesses generally arise to a complex interplay of several factors working together, which includes the biological pathogen, but does also include these social and psychological factors. And thus, this led us to the idea of the biopsychosocial model. So as we accepted that illnesses arose from biological, social, and psychological factors, this biopsychosocial model was born to understand this interaction. Basically, the model showing that it's very complicated, no two people are the same, and everything comes into play. So the fundamental assumption of this model is that health and illness are consequences of this interplay of biological, psychological, and social factors. So there's quite a few advantages of this model over the biomedical model, and that's because it addresses a lot of those disadvantages that I had mentioned for the biomedical model. So specifically, this model maintains that macro level processes, so like social supports, and micro level processes like those cellular disorders, the chemical imbalances, interact continuously to influence health and illness. Further, this model doesn't focus specifically on illness like the biomedical model did, but emphasizes both health and illness, so it can be used with prevention and promoting health behaviors, as opposed to showing up when the illness is there. So health isn't just the absence of illness, but something that's achieved through attention to all three of these factors. So, in addition to conceptualizing health and illness, there's a lot of clinical use and clinical implications for this biopsychosocial model. So first, this really expands the process of diagnoses, and this process of diagnosing is understood more fully when you understand how biological, psychological, and social factors interact to influence health. So a medical professional can consider all aspects when assessing and diagnosing a patient, and it gives a lot more risk factors to consider. It really adds a lot more detail to the picture of a potential diagnosis. It's not just, is there this cell pathology, or is there a specific chemical imbalance? You can add a lot more factors in that will help the accuracy of the assessment of a patient and possible diagnoses. Second, by adding psychological and social factors, this model makes explicit the significance of the relationship between patient and practitioner. If you think back to the third or fourth slide, and how health psychologists are involved in shaping health policies and looking at the healthcare system, think back to that conversation about how interactions with healthcare providers have influenced you and influenced your health. So this biopsychosocial model really highlights that the patient-practitioner relationship isn't something to be disregarded. So it's been really overlooked in the past as just an exchange. You need help, you go to a doctor or whoever, they give you a treatment plan and you leave. But we know when you include these psychological and social factors, an effective patient-practitioner relationship can impact positively how often people seek healthcare services or use them, how effective treatment is, how likely people are to stick to their treatment plan, and the resolution of illness, how well, how completely, and how quickly. So, for example, if you don't think doctors can help you because you've had terrible experiences, you're less likely to go and seek help when you need it. So this model has really helped highlight how important that relationship is. And it's something that was really overlooked before this model began to gain momentum and acceptance. So this all goes to say that there's definitely a need for and a use for health psychology. So since psychology arose as a discipline, psychologists have made an increasing amount of contributions to this healthcare field, answering a lot of important questions like why some people get ill, some people don't, how people adjust to health conditions. So think of adjusting to all this social isolation. What factors lead some people to practice health behaviors and not others? Like why some people don't take their medication and other people do. So as psychology's contribution to the health field grew, the American Psychological Association, APA, began to develop a task force specifically created to investigate psychology's role in health research. Now, this led to the eventual development of the Division of Health Psychology in 1978. Now, societal changes have really heightened the importance of health psychology. Over time, there's been an unprecedented increase in chronic or lifestyle-related illnesses. Simply put, people aren't dying for the same reasons today that they were a few centuries ago. People aren't getting sick from the same things today that they were a few centuries ago. And it's not just because, there's more hygiene nowadays, although of course that's definitely a part of it. So prior to the 20th century, acute disorders were a major cause of illnesses and death. Now, acute disorders are short-term illnesses, often caused by a viral or bacterial invader, and are usually curable. For example, in the 1900s, the influenza and pneumonia were the leading cause of death. But like I said, in the 20th and 21st centuries, there was an increase in chronic or lifestyle-related illnesses. And this is now the leading cause of death. And chronic illnesses compared to acute illnesses are slowly developing diseases, and people may live with these for many, many years and are often managed with treatment but not cured. So for example, in 2015, the leading cause of death was heart disease. You can't really cure heart disease, but you can manage it. So where does health psychology come into play here? Compared to acute disorders, social and psychological causes are implicated in the development of chronic diseases. It's not a virus that showed up and caused a chronic disease, necessarily. It's much less likely compared to an acute disorder. But there's a huge impact of social and psychological factors. Health psychology as a discipline, can identify these causal factors and research how they impact these diseases. And second, because individuals may live with chronic diseases for long periods of time, that's a huge area for health psychology to have an impact by helping them manage their chronic illness and research how chronically ill people accept their illness and adjust to changing state and treatment regime. Especially if you have to make major changes in your life to manage a chronic illness. Psychology is a huge field to investigate how people are doing with that and how to make it easiest, I guess, and as seamless for them. So this leads us into a bit of a discussion of how people conduct this said research in health psychology, which is a bit of a general discussion into science and research overall. But health psychologists, like I said in psychology, were guided by the scientific method. So health psychology as a division of psychology is no exception to this. And that means the contributions of well-trained health psychologists are comprised of theoretical, methodological, and statistical expertise. So a lot of health psychology research can be guided by practical issues, but about a third is guided by theory. Now, a theory is a set of analytic statements that explain a set of phenomena. So for example, a theory can be used to explain why some people practice poor health behaviors, like why people smoke if it's bad for you. Now, a good theory should be simple and useful. So it shouldn't be a huge, complicated, hard to understand thing. It should be simple, to the point, make sense, and useful for what you're trying to describe. think of that expression, if you've heard it, of keep it simple, stupid. Now, a theory is invaluable to guiding research and interventions. Theories provide guidelines for how to conduct research and interventions, and these guidelines are helpful also to allow later comparison between research studies or interventions. Because it's not enough just to have one Joe Schmo go out there, do one study on a theory, give you results, and that's it. You need to be able to compare things, because how do you know if it was a fluke, if it was just a one-off, if it's going to happen again? You need to be able to study things more than one time and then compare the results. So that said, it's easier to compare things that are structurally similar, or there's at least a clear guideline to how they were done, so you know what you can compare and how to structure something so that you can compare it. So for example, now here's where I said I like to try and give real life examples, because it's so much easier to understand things if it's not school jargon, but it's like real life stuff. Imagine trying to compare two hockey games. Now, obviously it's a bit chaotic, and I use this example because I'm really missing seeing the Leafs play and Austin Matthews. So it's a chaotic game, but there's a structure, there's rules, there's periods, there's, you know what needs to be done during the game, you know what the calls are, you can compare it, there's statistics. So there's a guideline. Even if two games aren't exactly the same, there's a guideline and there's markers that you know you can compare. Now try and compare two random recesses at school. Just take grade 4 recess and grade 2 recess and try and compare it. There's no guidelines. Kids are going to go out and do what they want to do on recess. So what are you comparing? How do you compare it? How are you measuring it? It's a lot more chaotic because there's no guideline. So theories can be used to give us a guideline so we know how to conduct research, so we can compare studies and compare interventions later to make sure they're not just a one-off, that they're helpful now and they're helpful again and in a bunch of different situations. Also, theories can be used to generate specific predictions that can be tested. So this is where we say you start with a theory and then come up with a hypothesis or a question that you want to test. And these predictions can be tested and then used to even modify the theory. So for example, testing theories of health behavior change, so making changes to promote good health behaviors and maybe stop ineffective health behaviors. Testing theories of these revealed that people need to believe that they can change their behavior in order to actually do it. So you need to believe that you're actually capable of making a change if you're going to be able to make that change. So from these findings, the importance of self-efficacy was incorporated into the theory of health behaviors. Finally, theories can help tie together loose ends about a subject. So sometimes there's a lot of different facts that don't clearly fit together in a certain way, and theories can help tie all those pieces together. So for example, why do people go off their diet? Why do people start smoking after they quit? So why would you start a good health behavior and then reverse it? A theory of relapse has been used to link scattered observations into a relapse prevention principle. So if you look at all these different scenarios that seem unrelated and consider it in terms of a relapse of sorts, you can use a theory of relapse and then create a relapse prevention principle that can be incorporated into interventions. So a theory can be really useful in that way to string facts together and make sense of them, and then develop intervention and protocols. Now, as said, a theory can be used to generate specific predictions to test with research. And there's a lot of different ways to conduct research, but much research in psychology is experimental. So in an experiment, participants are assigned to 2 or more conditions that differ in exact and predetermined ways. So if in one condition, people just get to drink as much water as they want. But in another condition, they can only have 2 cups a day. I have 2 groups, and I've determined that they're going to be the exact same in every other way except for how much water they can drink. Now, with a true experiment, participants should be randomly assigned to the conditions just to make sure, the groups aren't actually equal. Maybe this group of people are just super hydrated and these people are just super dehydrated anyway. Should be randomly assigned to the conditions. And in a true experiment, there would be a control group that gets no manipulation. It's just, status quo of whatever you're looking at. And the other experimental group or intervention group gets some kind of manipulation. So this group gets to drink however much water they want. That's my control group. This group is restricted. So you would later compare the manipulated group to the control group. But in an experiment, an outcome would be measured. So what do I want to see if I restrict people's water? What do I want to see happen? Hey! There we go. They always have to get one more. Enough! So what would I want to see happen? So maybe I want to see if they get more headaches. If they don't have enough water, some people get headaches when they're dehydrated. So there's an outcome, something that you want to measure to see the impacts of either group on the outcome. So when people drink less water, do they get headaches? More headaches than the group that gets to drink as much water as they want. Another example, people may research the effects of a drug to treat cancer, and the outcome may be the amount of cancer cells after a certain amount of time. So in that vein, experiments that evaluate the effectiveness of interventions or treatments on some sort of health are called randomized clinical trials. So people are randomized to different groups. So if any of you have seen Grey's Anatomy, I'm sure a lot of people have, think about all the clinical trials they're always doing. So Alzheimer's drug trial had a placebo condition and a medication condition. So in a randomized controlled trial, a prospective new treatment is compared either to a placebo or to a standard treatment to see the effects of the new treatment comparison. And this is especially important, especially when you take into account placebo or the idea that people get better just because they expect to. So overall, these methodological principles are known as evidence-based. So evidence-based medicine, and they're medical and or psychological interventions. So we do this with types of therapy as well, that have gone through rigorous testing and evaluation of their benefits and possible consequences like side effects through randomized controlled trials before they become the standard of care. So, I'll keep using the pandemic as an example just because it's right here, right now. But that's why vaccines take so long, because they need to go through rigorous testing to make sure that the benefits are there and there aren't any detrimental consequences before it becomes the standard of care and before they ship it out to the masses. So this criteria for treatment is applied to most medical interventions, and it's, like I said, it's now a common standard for psychological interventions. Another kind of research method that's quite common is called the correlational study. A correlational research design is used when you're measuring the relation between variables, or whether changes in one variable correspond with changes in another variable. So a correlation is expressed as a number ranging from -1 to +1, and it can differ in magnitude and direction. If it's a correlation of 0, it's not related. So an easy way to picture this is a scatter plot. So where there's dots, and if there's dots just everywhere, if they're not clumping, then there's no relationship. So I'd be like, what's the relationship between dogs and sushi? Probably not that big. A perfect correlation, if it was 1, negative or +1, would just be a straight line. So all those dots in the scatter plot would just be on one straight line. So, like I said, it can differ in magnitude or direction. The direction refers to the change in one variable when the other changes. So if a variable changes by 1 degree, what happens with the other one? So this is where it's either a positive number or a negative number. In a positive correlation, so like +1, the two variables go in the same direction. So as one goes up, the other goes up, or as one goes down, the other goes down, but they move together. So for example, if study time and grades are correlated at 0.8 or whatever, some positive number, this means that as grades, as the time spent studying goes up, grades go up as well. If sleeping and grades are correlated at 0.7, means that hours of sleep, if they go down, your grades are going to go down too. So positive correlation, they can go down together or up together, but they're going in the same direction. In comparison, a negative correlation means that the variables are moving away from each other in different directions. So, for example, if the amount of glasses of wine you've drank and grades are correlated at negative 0.7, that means the more glasses of wine you have, the lower your grades will be. So as one goes up, the other goes down. Now, when we're talking magnitude, magnitude is the strength of the correlation. So it can be positive or negative, but then how strong is it? And this is just how big that number is, regardless of whether it's negative or positive. So what I mean by that is if you have two correlations, one being negative 0.8 and one being positive 0.4, if you want to find out which correlation is stronger, ignore the negative sign or the positive sign. Those don't matter. So just pretend those didn't exist and just look at the numbers, which one is bigger. So in that case, the negative one would be bigger, would have a higher magnitude and be a stronger correlation because the number is larger. Now, correlational designs are really advantageous because they're more adaptable. You can do a lot more with them because you don't have to manipulate variables. This is especially useful in disciplines like psychology where it's hard to manipulate some variables, and it can be a lot less expensive. So when you do a survey and you're just answering a bunch of questions, it's very likely that that's just a correlational design and they just want to see if some variables are related. A disadvantage is that you can't determine causality. So you can't say this caused this. So there's an old saying, correlation does not equal causation. Just because things are related doesn't mean one caused the other. So with one of my other examples, I can't say wine glasses, like how much wine you drank caused your grades to slip because I don't know. Maybe there's another variable out there that I didn't look at, like maybe you didn't get any sleep, or maybe you just didn't study anyways. So just because two things are related doesn't mean one caused the other. So it's a definite limitation of correlational studies. So a lot of times, especially in health psych, we want to look at changes over time. And to do this, we can use what's called a prospective study. So these are used to look forward in time and see how groups of people change or how a relationship, correlation, between two variables changes over time. This type of study may be used to expand upon a correlational study. Like maybe you now know that there's this relationship right here, right now, but you want to see what happens in a month. So in health psych, a prospective study can be used to understand risk factors that relate to health conditions. So for example, a health psychologist may intervene in the diet of one community and not the diet in another community and see the difference in the rates of heart disease. Like if I took away all the fatty foods or any food that could potentially increase the risk of heart disease in one city but not in the other, and then see how many of them get heart disease later on. That's a prospective study to understand the risk factors for that health condition. Keep in mind that we would never do that study because ethics are a thing and that would just be terrible, but it's a good example just to draw the picture. So looking at prospective designs, a specific kind is a longitudinal study. In longitudinal research, the same people are observed at multiple points in time. So, for example, to understand what factors are associated with early breast cancer, you could follow a group of young women who could be at risk for developing breast cancer, whose mothers developed breast cancer, follow them over time, and see which daughters eventually developed the cancer, and identify factors that reliably associated with that development. Like maybe these people smoked, these ones drank alcohol, their diet. You follow them over time. Now, the opposite of a prospective study would be to look back in time, and that is called a retrospective study. And these studies look back in time to see how we got here, or to